Hello, everybody. Hope you're having a fantastic day. We are going to do our last of our new theorems for triangle congruence. So go ahead and start with this warm-up. Which theorem are you going to use for each of these questions? You're either going to use angle, side angle, or side angle, side. So look at what you have and make a determination. Okay, so like I said, we're doing our last three types. So we're doing side, 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 angle, angle, side, and hypotenuse leg, which hypotenuse leg is always just going to be with 90-degree angle or 90-degree triangles. So we're going to start with side, side, side. So basically this one is pretty common sense. If all three sides are the same, they have to be congruent. So if you look at these two examples, they both have a 1.7 meters. They both have a 2.4 meters. They both have a 2.3 meters. Therefore, they are congruent. So this one is the easiest, straightforward. All three sides have to match. Therefore, they're equal. Okay, so here's an example of one that works. Okay, we got a 24 and a 24, a 20 and a 20, a 12 and a 12. Therefore, they are congruent. This one right here is super close because we have a 38, a 38, a 54, and a 54, but our last side is not the same. So on this one, you're going to have to make sure you specifically look at all three sides, okay? Don't just look at two and think that that's good. You need to make sure all three sides match up. Okay? So using this rule means that we can then set things equal to each other. So for example, these are congruent. We got two sides that are 3. So now we're going to force the other two sides to be equal by setting them into an equation. So basically we're going to say that this 4x minus 6 and 3x minus 4 are equal. So we're going to set it into an equation. And then step by step, we are going to solve it. Okay, I am going to pull up this other screen because I know some of you guys are more visual. And so I want to do the solving part visually for some of you if you feel like you need to have it done visually. Okay, so 4x minus 6 equals 3x minus 4. Remember, there is this imaginary line that goes through the middle. So, and see, I've already even made a mistake on this one. On here, it should say subtract to the other side. Okay, subtract 3 to the other side is what we should be doing. So we're going to subtract 3x. And you do an x to an x, so it cancels here. 4x minus 3x is 1x, or you can just say x. Everything else comes down and stays the same. And then we will add 6 to the other side, and x is equal to 2. And so that is all we need to do. Okay, if it actually came back and asked us what the exact length would be, then you would just plug 2 into one of the equations. So for example, we could plug it in here to get 3 times 2 minus 4 or 6 minus 4 or 2. And you're going to know that you did it correct because if you plugged it in up here, you'd have 4 times 2 minus 6, 8 minus 6, or 2. And notice that those sides then are going to be the same. Okay? So I'm going to have you guys use that same thing to practice this one. Okay? This one, the equation is quite simple compared to that last one because we're only dealing with one variable. Okay, so go ahead and use the rule of putting equal sides together to solve this one for x. Okay, so hopefully you guys got x equals 4 for that one. If you did not, you might want to go back and redo your equation and see where you went wrong before moving on to this new rule. So this new one is angle, angle, side. So it says you have two angles and a non-included side, which means it's not between them. if those three things are congruent, then the two triangles are congruent. So again, I'm going to pull up this visual for those of you who need that visual. So notice that we have this angle and this angle, and this is your side. So the side is not between them. It's on the outside of the angle, okay? So this one, you have to pay attention to specific things in order to be able to really recognize it. Okay, so again, let's look at this example. Oh, I went all the way there. There we go. Correct examples. Let's look at this. All right. So, what? Give me just a second. I will be right back. Okay, so I actually went and changed that one because I didn't like the example. It wasn't as straightforward. So I went and found a different one. So our congruent ones would be an angle, and a side that is not with between them. That is why you cannot prove that this is congruent, because one of them shows that the side is between the two angles, and the other one shows that the side is not included. So because of that, this is not a congruent angle, and this one is a congruent triangle. Sorry, triangle, not angle. Okay, so notice angle, then the side is on the outside. Angle, side is inside. Automatically, you know that it's not angle, side. Okay? So, if we look at this, would this be included as an angle, side theorem? So, look at this. Look and see if first of all, if your side is not included. And second of all, look and see if you have two of the same angles. So, go ahead and check this one out. Okay, so hopefully you guys said yes to this one, and I did just kind of like a color coding. So the two purple angles are the same, the two orange angles are the same, and then our two green sides are the same. And notice that our side is not in between our angles, and so therefore, yes, it does work according to angle, side. Okay? So the last one we're going to talk about is hypotenuse leg, and it basically is we're only talking about it with a 90-degree triangle or a right triangle, okay? And basically it says if the hypotenuse and a leg of one right triangle are congruent to a hypotenuse and a leg of another one, they have to be the same. And again, remember, we're making sure that the hash marks are the same. So for example, we have this 1 hash mark here and a 2 hash mark. That means that the one A and D are equal, C and F are equal. Therefore, these are congruent triangles. Okay. It's a whole lot easier to recognize, in my opinion, on a right triangle, just because it's pretty obvious if the hypotenuse and a leg are going to be equal. Okay, so here's an example, and you're going to see a lot of examples that are in this manner for right triangles. They share a side, which means they have to be the same, and then the hypotenuses are the same, therefore they have to be congruent, okay? And you would just say, yes, they're congruent by HL or hypotenuse leg. Okay, and then we can use that rule like we did for side to actually be able to do some solving. So in this case, because we know that they're going to be equal because they're sharing a side, and we're going to make their hypotenuses equal to each other. So I'm actually going to pull up this other one so that I can do the work with you guys, because I know some of you guys are visual. So we're going to say 2x plus 2 is equal to 5x minus 19. This side is equal to this side. And again, we have our imaginary down the middle. So I am going to subtract 2x. It cancels it here. 2 comes down. 5 minus 2x is 3x. minus 19. I am going to add 19 to both sides, and I get 3x is equal to 21. And so I divide by 3, and x is equal to 7. And that's all I have to do. But if I wanted to come back up here and plug 7 in for x and just make sure that it's true, 2 times 7 plus 2 is 16. 5 times 7 minus 19 is also 16. So we know that we did our work correctly and we found the correct answer. Okay. So I'm going to have you guys try. You're going to do the exact same thing that I just did. Okay. We're setting two sides equal. Do notice, though, that this one, the hypotenuses are the ones that are connected, and so these are actual legs. But it doesn't matter because we're still setting them equal. So take a second to set these equal and solve for x. All right, so hopefully for that one, you guys got x equals 11. If you did not, please make sure you go back and check your work and see where maybe you went wrong, okay? So using the three types that we've done today, side, 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 angle, angle, side, and hypotenuse, leg, I want you to determine which of those three would you use to prove that these two triangles are congruent. Okay, so which would you use to prove that these two triangles are congruent? Again, side, 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 angle, angle, side, or hypotenuse, leg. And lastly, which one would you use for this example? Would you use side, 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 angle, angle, side, or hypotenuse, leg? All right, so now that you guys are done with this, you're going to do a quizzes assignment. Remember, you need to get a 70%, so you can redo it as many times as it takes to get to that 70%. If you are confused about any of these, I would recommend either rewatching the Ed Puzzle or coming to office hours so that I can help you. And if you have not started writing down your list of all 5 of the different types. So we have angle, side, side, angle, side, 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 angle, angle, side, and hypotenuse, leg. Those 5, you're going to want to have a cheat sheet when it comes to test time. So if you have not done that yet, I would highly recommend doing that. Have a fantastic day, and I will see you guys later. Bye.